Okay, for this video, I'm going to cover the method of Diophantus. So this method is concerned with finding explicit formulas for Pythagorean triples. A Pythagorean triple can be seen as being a unique one. We could say is going to be any point on this circle will make us a Pythagorean triple if we can find that point on the circle. So we could say G here is, so it has to do with well, if you remember the Pythagorean theorem, it has to do with the sides of a right triangle. So a squared plus b squared is equal to c squared, pretty much, right? Or in this particular case, g squared plus h squared is equal to, well, 1, since this is a unit circle. And G and H are going to be numbers between 0 and 1. So the Diophantine method, or Diophantus's method, is going to be we need to find a parameter that G and H are related to, and that we can plug into some functions. So a pair of functions. One function is going to be G, and the other is going to be H. And I can plug in this parameter, and that will give me the numbers. So you could say, oh, well, what about sine theta, cosine theta? That's something we could use, right? But then our parameter would be a degree measurement, and I don't know about you, but I don't know how to calculate sines and cosines by hand. That's pretty difficult. So this isn't giving us really a method to calculate sines and cosines by hand, but it's giving us some enlightenment about the unit circle that's going to be really important for trigonometry. It can be going to be really important in calculus. So the whole reason I'm doing this is it's just a little bit enlightening if you're studying trigonometry, geometry, calculus. So I'll just get right into it. So we have the first relation, G and H, we know is G squared plus H squared is equal to 1. That gives us the circle. And then we have this line here that goes through these 2 points, -1, 0, and G of H. So that line is going to have, well, we'll just write the equation of the line. Well, I know it's going to be y is equal to t times x minus 1. T is going to be, in this case, our slope, and that's actually going to be the parameter. And the reason we're using that parameter is because I know each point on this curve corresponds to a unique slope for that's corresponding triangle. This triangle, the large one, not this small one I wrote, because for this method, this large triangle is important. Okay, so I know if I can find a function from that slope to that point, then I'll have found what I need. So that's going to be t. That's going to be our parameter. So I know t. So what does t equal? So if I have this point, what do I know t is going to be? Well, I know it's going to be the slope of that line. And I know the slope is the change in y over the change in x. So it's going to be h divided by g plus 1. So for instance, if I'm going from this point to that point, I go 1 up, or I'm sorry, h up and g plus 1 over. So h over g plus 1. So this gives me h is equal to t times g plus 1. Okay, so I know h is equal to t times g plus 1, and I have g and h in a function, so I should be able to find out what, if I plug this in, I should be able to solve for g in terms of t, and that's exactly what I'm going to try and do. So I have g squared plus h times g plus 1 squared is equal to 1. Okay. I'm sorry, that's t. Alright. Now I have a relation. I have g and t as a relation here, so I should be able to solve for g in terms of t. And this is actually going to be, this is a quadratic formula, so it's going to give me two values. It's going to be one value for if g is over here, and then the other value is going to be if it's going to be -1 basically. You can see that because the first relation is a circle, and then we have the line that's going through it. So I'll just go ahead and get started. So that's t squared times g squared plus 2g plus 1 is equal to 1. There's g squared there. Okay, so basically all I did was I distributed I squared this term here, so that's t squared, and then this term squared is g squared plus 2g plus 1. Now I'm going to distribute in the t. So I guess I'll do it like this. G squared t squared plus 2g t squared plus t squared is 1. And we've got a g squared there. Okay, and so remember, I'm solving for g in terms of t. So I'm going to want to isolate my g's and write that as a quadratic formula of g. And I'm going to treat t like it's like it's just a regular number. So I have t squared. So I have my g squareds here. So I have t squared plus 1 times g squared. Okay, and then I have plus t squared g, 2t squared g, actually. See this term here? I have 2 times g times t squared, so I'll write 2t squared g. Okay, so here I've isolated my g squared variable by factoring out a t squared and a 1. So in other words, if I multiplied that in, I would have g squared t squared, that term, and g squared multiplied by 1, that term. Okay, so prerequisite to this video is factoring in algebra. So this is going to be everything that we're doing here, and completing the square actually. So I'm going to have several videos on completing the square, and the whole reason I'm even interested in that is basically for this. And for a few other things. Completing the square is extremely useful. So if you don't know how to complete the square, definitely figure it out. But if you understand the quadratic formula and you just happen to have the quadratic formula memorized, I do have it memorized, but I don't ever use it. I just complete the square because I think it's just as fast, really. Or maybe not. I don't know. So we're going to go ahead and get started on completing the square. I really don't have enough room to do it, so maybe I'll just go ahead and erase this and rewrite it. So as long as we get what's going on here, so just to recap before I erase that, what we're looking for is the parameter t. We're trying to write g and h in terms of t, and we know that t is going to be this ratio, that side divided by that side. And I know we have, unique ratios for each one of these points along that curve, so that they'll correspond into a g and an h value. So I can just kind of say, well, I know that, I can take some really small number here, like, I don't know, 1 over 100. And then once I have g and h in terms of t, I can just plug that in and it'll give me g and h, and I'll have a Pythagorean triple. In other words, g squared plus h squared is equal to 1. Now we'll see how this applies in a second. I'll make more videos showing that. But this is parametrizing the unit circle in terms of the ratio of the two sides of that triangle. So let me just write this up here. So that's t squared plus 1 times g squared plus 2t squared g plus t squared minus 1 is 0. And also, another reason I'm doing this is that this method is extremely useful when we start talking about integrating trig functions. That's really why I started looking into this, but let me go ahead and get started on solving it. So g squared plus 2t squared over t squared plus 1 g plus t squared minus 1 over t squared plus 1 is equal to 0. Okay, so I'm going to focus on solving this. I'm probably not going to talk too much about how I'm doing it exactly, but this is going to be completing the square. And you can look into that on how to do it afterwards.